Hello again, it's Lawrence, KL7LWE2XPQ, signs of a moose. Well, this is part deux of the antenna remediation and check, and again we're still in snowshoes. It continues to be a beautiful day here in south central Alaska, and the mountains there, it's been gorgeous. But we didn't get to see the other end of the Marconi. We talked about it at the beginning, but you saw the feed end in the first video, and this is the other end, supported by this 65-foot fir here, and it's a lot of pulleys and stuff to keep that up. Now the problem we've got, of course, is that nesting a Marconi, especially a short Marconi, in a forest isn't such a good idea. Lots of losses, and you know, a lot of absorption. These, if you imagine, each one of these birch trees is a capacitance to ground, shunting the RF. You know, it's got a series resistance, but if you add all that lot up, when the sap is flowing, life isn't good. So your tuning can vary on a day-to-day basis or an out-and-out basis, and yeah, life is not good. So when it greens up, my ERP, my effective radiated power from XPQ, just drops, and what you'll see is when we do the WSPR results that my ability to hear improves theoretically compared with my transmitting power, and that's just because the most of it is being absorbed by the trees. I go from about 20 watts ERP down to about 5. So to stop that happening, we do two things. First of all, you can't see it, but this whole forest here is an earth mat with welded wire, copper radials. It's about 100, 200 foot radials, and right out to the base and beyond of the end of the Marconi up there. You can see with the 8-foot spreaders is covered. So that actually stabilizes the field beneath the antenna, and actually makes it a bit easier to deal with. The resistance or the resistive impedance doesn't seem to wander so much. So the second thing we've done is we added more top cap. I'm not going to see if you can see this or not, but I'm going to zoom in, and we're just remediating at this moment. It's not up its full height, but you can see there's a wire attached to that top, and this is additional top cap, goes past this tree up here and ends up over there on that far tree there. And at the moment I'm just tightening it up. What it really means is the effective capacitance, the top capacitance, is actually quite high. In theory, we're actually not very far just short of a quarter wave, so the amount of tuning inductance that I have to deal with, and the losses and the impedance presented at the base of that vertical, is actually a lot higher than, or a lot lower, depending how you look at it. It's easy. So adding a lot more top cap in this case means that we're getting closer to a quarter wave. So I can't remember how many puff of top cap it is, but it's quite extensive. So my tuning down at the bottom there through the variometer is less than 100 microhenry. So that's what we do here. Now obviously the issue is that the effective height of this Marconi gets reduced, because we've gone from 72 feet at the far end to 60, and probably 55, 60 at the other end. So our effective height goes down, but the efficiency sort of the top cap sort of helps a bit, and we probably win. In fact, I know we win, because if I compare my radiated field at 1 mile with I've got a field Fox level measuring set, goes from basically DC to 6 gigs, and put a small vertical on that, and we measured it, and adding this top cap here actually improved my field by 1 dB at a mile, and it appears to be omnidirectional. We've done some tests there with the field. So adding this top cap, additional top cap here, some things are negatives and some things are positive, but we probably come out the positive side. So that's the what we've been doing. And the second thing is we need to try to keep the wire away from that tree there. And the reason is it's fine at 475 kilohertz. There isn't a lot of voltage in true terms on the antenna, probably a kV or two. But I want to try to load the bottom up in a minute. Well, not a minute. In a few days' time on 137 kilohertz. And of course the voltage is going to go sky high, and if I have the wire running close to the tree here, we can either have a conflagration or some tuning mishaps. Now the transmitter doesn't complain because it's protected, but the last thing I need here is a forest fire. So we'll try it anyway. At the moment I'm just tensioning this up. It was stuck in the tree last night, so the stations that I worked in Japan and the east coast there, even the top cap was stuck in that tree last night. Didn't affect things very much. In fact, I couldn't really see the differences in tuning. Anyway, enough of me rambling on. So that's the other end of the Marconi, and greetings from the moose. I'm going to go wandering over here. I did want to point out something else that we do here. I don't know if you can see that over there. That's the green box into the sun there. That's the head end for the cable service that runs underground. All my services are underground. That's 7.5 kilovolts out there, and then down to two phase, 240, 110, 120, whatever you want to call it. And it runs underneath the house, and it goes into a box. I just want to show you. So I'll go past a bit more snowshoeing, and it's still deep. It's probably 5 feet deep here, and the wind scoop. I'm trying to noise mitigate here as much as I can, so everything comes into the box, the metering box there, and the main isolation. And you probably see that big grey box beneath there. So after the main fuse and my fuse boxes and the isolators there, it goes into that grey box, and that's two 200 amp Corcom. They're actually 3-phase RF filters, huge, and they're actually not too bad. Even at 137 kilohertz, it stops common and other noises from going up the inbound, coming up from the mains, from the road there, and secondary, if there's any RF that's going out from my house along the power lines, it also gets shunted at that point. And you can see the transfer switch there to the right. That's for the generator, because we do lose power a fair bit. So that's how we stop interference. The only new issue we got here is our illustrious power company has decided to install in the meters there TWACS, TWACS, which is what it does. It puts short current pulses on the 60 hertz supply in a coded format, which gets transmitted back to the substation and read, and they can supposedly do one direction or two directions. And unfortunately what that does is it puts lots of transients. It makes the mains or the AC supply coming in fairly dirty, and my Corcom unit will have nearly no effect, because well, relatively nearly no effect at all, because these transients, these pulses they put on are slow but large. Put it on top of the AC waveform there, and it doesn't seem to, no matter what I do with RF filtering. So the noise level's increased here a bit, but you'll see that I've actually still got a standard mechanical meter at this location, which is great. I managed to persuade the power company for the time being to keep me mechanical, so I didn't have a turtle, which was on before, which had lots of RF, and then they changed the whole of the houses here on the estate to TWACS, and I'm still read mechanically. Anyway, so it is another beautiful day here, and I'll wish you 73s and all the best from Alaska. And thank you very much for those that either transmitted to us or received or decoded XPQ last night on 137 or 475 kilohertz. 73s from Alaska, KL7L, WE2XPQ.